Hello everyone, I am Sheikh Hussain and today we are going to be looking at evolution of galaxies. For example, we've obviously got the early galaxies or the elliptical galaxies, which are formed from a young age where stellar gas and dust are formed. Then we've got the second stage where they start to flatten and little spirals come out. Over here they are slightly built elongations, and next it is almost forming a spiral, because, or most should I say that most of the scientists just actually think that this might be a quasar, or they get confused with it because it kind of looks like the materials spewing out from a quasar. The next stage of a galaxy is are Barrett spirals or spirals. First, when the spirals are formed in the young age, they'll be having first a ring around them full of cosmic dust and gas. But in the center are full active stars. Next, at the bottom we have Barrett spirals, where the other two parts of the ring are clumped together by the black hole, and the other two are elongated from it. Next, we've got the intermediate spirals, which will eventually break away and become into irregular galaxies. First, it directly becomes into a spiral. There is no columbation, but it will still have a little bit imperfections. So the early stages from these three galaxies. Next, we've got the first stage of the galaxies, where the galaxies has formed a complete spiral, but it is not yet bigger or a complete perfect spiral, as there are slight changes to these that has to be made. For instance, spirals were in this galaxy are completely clumped together. Well, at the down part, the intermediate spirals have already formed with already like, at least the maximum number of the intermediate spirals should at least be 12 arms for the intermediate spirals. Next, we've got the Barrett spirals. They are basically something like something in the center, and just something spewing out over here and something spewing out in the opposite direction. This is due to the speed at which the Barrett spiral is going at, or should I say the speed of the black hole inside the center, or how big its accretion disk is. Next, we've got the fully evolved spirals. Next, we've got the fully evolved spirals, which contain, again, this is a perfect spirals with no imperfections, and these are completely evolved, or you can just call it as adult galaxies. At the bottom, we have a complete evoluted galaxy. This time, at least some or the other tails or arms might have collided together to form another few arms. At the bottom, we've got the Barrett spirals, which is about to give a Barrett shape due to as its speed, or should I say the elliptical force from which it has formed. Next, we've got the kind of old age spirals, where at least there should be a galaxy affecting it. For instance, as you can see over here, there are a little bit imperfections from a distant galaxy, or should I say from a dwarf galaxy. For example, our Milky Way has a dwarf galaxy, Sagittarius, and our Milky Way is completely not like this spiral. It is enlarged, something like this. So this is the old age of the spiral again. And for the intermediate spirals, it has again gained at least 15 arms in this old stage. Next, we've got the Barrett spirals, where now it has flattened in time. Or should I say that these arms have bent a little due to the gravitational force of the black hole, or something might have changed in the black hole behavior. Next, we've got the very old age galaxies, where the galaxies start looking very irregular, and they start to fall out of shape. There are two causes that can this happen. Number one, the central black hole might have exploded, or it might have collapsed into itself. So this is a slight imperfection, And as you can see over here, for the intermediate spirals, these spirals can stay forever, but there should be a galaxy colliding into them to form this irregular shape. So this is the one. And next we've gone to the down. Now the barista spiral, as I said, it is sucking the outer, as I said, it's sucking the outer layers inside. So the black hole is basically devouring the outside stars which used to be safe, for example over here, but now they are being sucked in to form a type of shape. Next we've got the irregular galaxies. These irregular galaxies are the cause of intentional collapse due to, as I said, if the black hole disappears or it reappears, or a new host black hole has collided with the galaxy, these things can happen to the spiral galaxies. Next we've got the irregulars. As I said, these are the whole irregular lines. As I said, if a galaxy collides into a galaxy, it will become an irregular galaxy. Even this guy actually turns into a regular galaxy over due to time. All the stars fall inwards and there is just supernovae and these outside spewing out, and this guy chooses how many stars or what forms. Next over here we've got dwarf galaxies, which are a bunch of small galaxies where the outer black hole's power has been reduced, like this one. Yeah. The barren spiral galaxies also have the same effect. As I said, the whole galaxy collapses into itself, becomes irregular as the matter starts spewing out, supernovas start happening. Then it becomes just a dwarf galaxy. When there is a small black hole, or either there is a large one colliding into it, the small black hole will have the opportunity to take all the gas and or borrow it from the host galaxy to make its own galaxy with stars and nebulae. So the irregular galaxy is an example of irregular galaxies such as 1C00IM, or you can see edge of spirals. For example, you can take something like the Cimbero galaxy, which is basically showing its sides. Next we've got mergers. As I said, every single galaxy actually merges. For example, this small dwarf galaxy is sucking the whole host stars matter. As I said, it becomes irregular, then it becomes a dwarf. Over here, as I said, the Cimbero galaxy, these are actually also edge on spirals. The Cimbero galaxy is over here. And as I said, the mergers and interactions, galaxies can also have different interactions. For example, another galaxy is imperfecting it, even from light years of distance. That galaxy, it can be 0.0, but it will never be completely zero, as there is a little gravitational force. This galaxy is a galaxy, also known as a bubble galaxy, had been affected by one of its neighboring galaxies, which scientists thought that it passed through and it ripped into the galaxy's layers, and it just formed the ring around it. Next, we've got these two elliptical galaxies elliptic galaxy, something like this. Even those even elliptical like this, even galaxies can form elliptical due to old age, or even when the galaxies are born, they are elliptical. When they are very old or when the star production has closed, they will leave remnants outside and will not be a spiral due to their little gravitational forces. And this is also a galaxy being affected by its partner galaxy at the upright. So this galaxy is supposed to be like this, but the upright galaxy is pulling on it, causing this shape to happen. And in a few million or billion years, this galaxy might collide with that galaxy, the heavier galaxy. As you can see, the elliptical galaxy is greater, which has small dwarf galaxies, but it's affecting the smaller galaxies. So galaxies are also like cannibals, where they take in energy from different galaxies or just collide with them. So now this is a host galaxy and this is a dwarf galaxy, which is colliding again and again. And these are a few elliptical galaxies. This is Sagittarius, the dwarf galaxy, which again collides, or should I say, it's a dwarf galaxy, but it is not a completely dwarf galaxy, as this guy might have entered over here and then being caught in our Milky Way. As you can see, it is starting to shed out its layers from the Milky Way, and it goes again up, it goes again down, shedding its layers from the Milky Way, and it comes back down. So this guy actually came over here and doing over here. So now our galaxy has like this, but also another ring over here. How should I show it? Yeah, like this. Our galaxy is over here, the central black hole is just pulling Sagittarius over there, so it is going to be like this. Next, we've got to the current situation in which the Sagittarius galaxy has come. It has at least collided with the Milky Way 2 times, disrupted many billions of stars, millions of stars. Hope you learned something. Thank you.